Good morning, good afternoon, good evening, everyone. Welcome to our second webinar in series of 4 on PSCAD version 5 features. My name is Afshin, and alongside with my colleague Darshana, we will be hosting today's webinar. I will cover the first part, introducing PRSIM, and then I'll pass it to my colleague to take us through PSCAD Initializer. Before starting, just a few housekeeping items for today. Please make sure to use our chat box, introduce yourselves, and we'd love to know more about you, the way you are planning to use all these new features. And as we go through the webinar, please feel free to ask any questions you might have. Our experts will keep an eye on the chat and try to answer all your questions and as we go through the webinar, as I mentioned. So we'll also provide our support contact information at the end of this webinar for more specific questions if you have any. So now let's start with the first part of the webinar and focus on PRSIM. Let's see what we have ready for you today. We'll start with a short introduction to PRSIM and why we essentially started the whole project. And based on the identified needs, we look at PRSIM offerings and its most important features. After that, we'll take you through simple steps to use this new platform. Finally, we will wrap up the PRSIM part by launching the software and trying to use it for a number of different applications. At the end, I'll pass it to, again, my colleague Darshana to take us through PSCAD Initializer. And finally, we will wrap it up. So now let us start with PRSIM. With high penetration of renewables into the traditional power system, we have seen an increasing interest towards EMT type studies. One of the main obstacles in such a transition has been translation of load flow data from large databases to PSCAD. And that's essentially when PRSIM comes to the picture. It's there to bridge this gap, and our development team has come up with Power System Importer tool known as PRSIM to facilitate importing data from PSCC or Power Factory Island as two standard network database formats. You may think of it as an intermediary platform where you can dump your load flow information and it will do the necessary sanitation and post-processing to make it ready for PSCAD studies. Now let's see what makes PRSIM unique and a must-have option coming from large networks to PSCAD. Here we tried to cover a selection of handy features to get you started on PRSIM and skip the more advanced ones for time being. We are planning to have more specialized webinars / tutorials for those advanced features in near future. We are aware of the fact that users may experience many challenges during the transition to PSCAD. To mention a number of those challenges, we are talking about inconsistency in the format of data files, the lack of vital pieces of information necessary to perform transient studies coming from those load flow platforms, the presence of data entry mistakes in very large databases, which is inevitable, and validation of the translated data in case you face mismatching results. And finally, yet importantly, the integration of existing EMT models during the translation. So you might already have part of your system built in PSCAD, or you have a library file and you like to see that as part of the transition as well. To address such challenges, PRSIM benefits from a number of features, a few of which are listed here. So it converts PSCC and Power Factory XLN data files to PSCAD version 5 as well as 4.6. And that's part of the network data import strategy. It imports detailed dynamic and sequence information if available. So in case you would like to see more detailed representation of your system, for example, rather than having a simple AC source, you would like to see a combination of synchronous machine, governor, exciter, and all those detailed pieces of information. So that's doable through PRSIM. It also allows you to import location data for auto routing and a seamless graphical representation. So obviously, most of the time we'll see that clients have their SLD files, the single line diagram files already built in other platforms, and it's better to avoid doing the same thing again and again in PSCAD. And what can happen through PRSIM, we use that information and we automatically build your SLD single line diagram, and then we will pass it to PSCAD. It also forms NETEQ for unexpanded segments of the network. So it might be the case that you bring the whole circuit and the whole system to the PRSIM, and then you are only interested doing transient studies on part of that system. And at that point, you can leave the rest to be modeled as a network equivalent module through PRSIM. And it also re-initializes the generated PSCAD projects to save your time and effort, because we are aware of the fact that once you build a PSCAD case through PRSIM, you might take it to PSCAD and do lots of different tweaks and modifications, like adding control signals, monitoring signals, and all those kind of extra pieces of information. And then what you might want to do at that point, after adding all these extra things, is to, for example, try a different scenario, a different load flow operating condition. And PRSIM allows you to bring that new information and translate it to the existing PSCAD case and update the operating condition of the system. And finally, it allows integration of user-defined PSCAD components in form of a library file to be used during the transition to PSCAD. As I mentioned earlier, there might be models that already built in PSCAD for different purposes, and now you would like to use them during this most recent transition to PSCAD, and that can be done through PRSIM as well. Next, we will focus on the translation process itself. So now let's see how PRSIM works. The whole process starts with running load flow results in either PSCC or Power Factor Dixilent, and once the solution converges, saving it into the right format, which is shown here. So currently, we support up to raw files version 33 for PSCC and only DGS files version 6 for Power Factor Dixilent. So these are the right formats we're expecting your power flow data to be present. And then once you have any of those two files, what you can do, you can start the process. You have a PRSIM case, and once you have that power system information ready, all you need to do is to, after creating that PRSIM case, is 3 simple steps: import the information, expand your desired study area, and finally export it to PSCAD. Again, 3 simple steps: import, expand, export. When you install PRSIM, obviously it comes with many standard examples, which are listed here. But today we will use the Contour to Area system alongside the IEEE 9 bus to test some of its main features and to learn more about how all these things come together. So at this point now, let's launch the software and try to see how all these different features come together and can help us with transition to PSCAD. The very first feature to be tested will be network data import. Now I'm going to switch to the first case. So at the beginning, let's just focus on the PRSIM itself. This is the environment of the platform. And as you can see, it's very similar to what we see for PSCAD version 5, and it has been done intentionally to make the transition very smooth for our users. The very first thing we recommend is to just check your licensing, make sure you have it activated and you are good to go. At this point, maybe just try to go to the View tab, and under the panes, select all different panes that are available, because we're going to use most of them today. and it will be good to see all of them here. So back to the home button and home tab. Let's explore the environment itself a little bit, see all different parts of PRSIM, and then eventually we start creating a PRSIM case and importing the contour to area system. So starting with the PRSIM environment, when you open PRSIM, you will see that there is a workspace like PSCAD. And under this workspace, we have a master library file as well as a PRSIM library. So the master library is nothing more than the PSCAD library. So it includes all PSCAD models, for example, here for version 4.6. And if you look at the PRSIM library, we have a selected number of models from that master library. Obviously, there are more to it why we keep this PRSIM library. But for now, let's say that we have selected number of those components. We keep it during the transition to PSCAD to model your study area. So now that we are a little bit familiar with the environment itself, let us start with creating a PRSIM case and importing our first case. So before starting that, always we recommend to make sure that you choose the right target version. Here we are looking at two target versions. We are talking about version 4.6 as well as version 5. So for the first import, we will just focus on 4.6 and eventually we will shift to version 5 and see how it performs. So always make sure to select this option first. Now I'll go under the file, then go to the new tab, and then I will assign a name as well as a folder path where I want to see my raw file or any kind of information that is supposed to be imported to PRSIM. So let's call it test 1. I also assign the path again, and now I can click on create. At this point, you will see that a new project will show up under the workspace brand, and this is essentially a PRSIM project. There are different ways for importing the information, the load flow information. Usually, I personally prefer to just do a right click here, keep it simple. For the first case, I'm looking at the PSSE file. So as you can see, there are two categories for importing. There is PSSE import and there is power factor import. For now, let's just focus on PSSE import. And under PSSE, we have different set of files that can be imported. For now, for time being, let's start just with a raw file. And as you can see, it lists all different versions of raw file that can be imported. So it takes me to the folder that I assigned to my case, and I have the contour to area system ready. I again reiterate that I have already run the system in PSSE, so I make sure that it converges the power flow, and then I save it to the right raw file version. And now that it's ready, I can just open it in PRSIM. So I want to, at this point, bring your attention to two things that happened. We have an output window here, which essentially communicates with us what is happening behind the scene. So we imported a raw file version 33. It also tells us how long did it take for updating the network, what type of parameters and components we are bringing into the system, and essentially a good understanding of what is happening. Another important thing happening here, we have a network table, which just got updated, and essentially it keeps tracks of all the information from that raw file. So at this point, you should be able to switch between from this drop-down list, all different categories that are provided to you to look at different components that are imported. For example, from the bus table, I can go to the load table to look at the two loads that are existent. So it's a really cool feature to see all the information here. And as I mentioned earlier, PRSIM keeps tracks of all this imported information. At this point, we can now start expanding the study area. Let's say that I would like to expand the network starting from bus number 60. There are different ways for expanding the system, the study area. One way is starting from the network table itself. I do a right click on this bus which is already selected and I say create, and it allows me to drop it wherever I would like on this PRSIM canvas. And as soon as I drop it, the source connected to the bus will appear as well. I can click on R to rotate this bus. As you can see, there is a plus sign right beside this bus bar. And that means there are other parameters and components in this system that are still connected to this bus. And since it is not fully expanded, this plus sign appears. So if I click on this plus sign, those components which are connected to the bus and are not existing on the canvas yet will be added to the canvas. And I can continue by clicking on this plus sign, or another option for expanding the bus is to go to these two options that you see, these two icons. The very first one says expand bus. And as soon as you click on it, it will show you a list of all the buses available for further expansion. So far I went till bus number 65. Let's say I will select bus number 66. So it allows me to drop it wherever I like. And I can click on the bus to do the necessary realignments of the lines and everything and make it look better if necessary. Now let's try the last option, which is expand all. And the difference is that rather than expanding one by one, it will expand everything. Let's say after expanding bus number 66, I will just select bus 67. Again, this is similar process. It allows me to select that bus, drop it, but let's see what happens at this point. Everything will get expanded. So now let's say that we are happy with what we are seeing here. Everything is expanded on the system. And you might want to do just a small adjustments if necessary, like this. But let's say you want to make it look better and have everything on the right side of this canvas. Obviously, there is not enough space. What you can do a right click, go to the canvas setting, and increase the size of the canvas. The maximum available for version 4.6 is the oversized canvas, but obviously we have that 100 by 100 jumbo size available for version 5 as well, which is a cool feature allowing you much more flexibility if needed. And now I can eventually take my bus to that freer space and do the necessary alignments. So at this point, we have expanded. We have another cool feature, which is a bird's eye view, which can take us to wherever we want in that study area and play with it if necessary. So now this is the full expansion of the case. And we are happy with what we are seeing in the study area. It's time to, after import and expand, time to export. So there is an icon that says export network. All you need to do is to click on that icon. For timing, we don't look at all these different items. We just click OK. And let's see what happened. I'll take my PSCAD case and put it right beside my PRSIM case. As you can see, it places properly all those components at the right locations on the PSCAD canvas. And to give you more idea around what really happens here, so we have this network table which holds the power flow information. We have this PRSIM case and we have this PSCAD case. What really happens behind the scene is that let's pick this load and look at its view network properties. And it lists all the important parameters for the load. So we have an active and reactive power, which is coming from the network table assigned to that model. And what PRSIM does, it will read this information and it will make it ready for a PSCAD case. For example, here, if I go to the PQ load, I'll see the same active and reactive power, but obviously divided by 3 because we are talking about per phase values. So this is just a simple calculation, but obviously for more detailed models, complex models, the level of calculations will get more complicated. So that's essentially what happens, and this is the whole story. Now that we have that PSCAD case, we need to run it. Obviously, PRSIM doesn't have the engine to run the PSCAD case. What you can do at this point is to launch PSCAD. You have this cool option that will allow you to send everything to PSCAD. And now we have our PSCAD case. Let's say at this point you're interested in doing a load flow comparison. You can quickly add a load flow, a multimeter, check active and reactive power, for example, to make sure everything is working fine. Obviously, there are more to it. You might need to do more adjustments, but for time being, what we can see here, active power 699. Let's go back. Another cool feature for PRSIM. If we go back and we want to make sure we have the right load flow results, we can do a right click on the canvas, go to the canvas setting, and then display the power levels, which brings 2 different values to each component. For example, for this source, AC source, we see again that active power we just saw in PSCAD, 699. So at this point, we are happy. We can also apply short circuits to make sure everything is working fine. And then at that point, you can continue your PSCAD studies. So that was the first demo for importing network data. But what we saw today was a time-consuming process in the PRSIM canvas, because as you noticed, we had to go through each single boss, click on them, expand them, and see the study area which we are happy with, and at that point, send everything to PSCAD. But as I mentioned earlier, we have this auto routing option. We try to improve this expansion process using system coordinate information. Let's see how that works. So I'll keep the same file. Let's unload the PSCAD case. And let's Control A, select everything, and then delete. Nothing gets deleted from the network. It's just the graphical representation of these components, which is getting deleted from the PRSIM canvas. Do a right click on your PRSIM case, and this time try to import the location data. And we have already, from the SLD file in PSSC, we have already exported the location information. We open it, and then we will select expand all. So based on that location file, PRSIM will identify where to place all these components, which are linked to that location file. And as you can see, with a single click and maybe very small modifications, we can easily have our PRSIM case ready. And let's say at this point you are happy with what you're seeing, and then you can take the same steps, exporting the network and then running it in PSCAD. So as you can see, it makes it much easier to just rely on the location information and then doing the transition to PSCAD. Users may add more details to their PSCAD models, as I mentioned earlier, by importing dynamic or sequence information, if available. Now let's look at this again. The same case and the same information, but now on top of the location information, we're gonna add dynamic information. Let's see what happens when we do a right click on this PRSIM case and import DVIR file. Again, we have already created this DVIR file. format-wise, it's compatible with what we are expecting. So we select this DYR file, we open it, and now I would like to bring your attention to another table which we have for holding your power flow information, which is called dynamic data. And as you can see, as soon as I imported the dynamic information, it will get updated with the existing dynamic information. We are talking about a Genero, which is a synchronous machine model. We are talking about an AC4A exciter model and TGov1 for a governor model. But how can we use this information during export? Because so far what we saw was taking the information from the network table and then passing it to PSCAD. So let's say that at this point again, you are happy with the study area and you want to export it, but this time you want to include the dynamic information. And that's what you need to do during export. You're going to click on Include Dynamics and then activate this option. And let's see what happens. Let's put them side by side again. And as you can see, rather than seeing an AC source, which was happening before, we saw that this AC source before, now a combination of all those three elements that we mentioned will show up in our PSCAD case, which is essentially an exciter connected to a synchronous machine as well as a governor. So that's another cool feature on PRSIM, which allows us to bring sequence dynamic information and integrate it into the export process and use it for creating a PSCAD case. So let's now move to the next feature, which is a user-defined library. And for this, I'll try to now use XML file as another set of power flow data, which is supported by PRSIM. So I have already created a case for this feature, substitution library, user-defined library as we call it, which is essentially an empty PRSIM case. On top of that, what is extra, I have loaded a PSCAD, PSLX file into PRSIM. So here, let's imagine that these models, 4 models, they do not exist in PSCAD. And what we want to do, we want to rely on this detail model. For example, let's say that this AC line, which is a frequency-dependent model, doesn't exist in our PSCAD library. And what we like to see is that we use this model during the export process. So let's go back to the PRSIM case. Let's import the information, but this time let's just focus on XML file. And for this case, we are looking at the IEEE 9-bus standard case, exported from Power Factory in an XML format, DGS version 6, and we open it. The same stuff will happen. The output window will keep track of everything. The network table and dynamic table will get updated simultaneously. That's the difference. That XML file includes all the different information we talked about in the previous example, where we just looking at the raw file, location file, dynamic file, sequence file separately. So that's the beauty of this type of file, but obviously there are other challenges to it. But now what happens is that at the same time, everything will get imported to PRSIM. And let's say again, since coordinate information is available, we click on expand all, and all of a sudden everything will appear. Now at this point, we are happy with what we are seeing and we want to export it again. So we click on export network. And that's where this is only one way. There are obviously more to it for a user-defined library, but that's only one way. Since we have already loaded the PSCAD library file into our project branch, we can come to the very last option, which says user library. And we see from a drop-down list that this name appears, IEEE 9 user models. And those are the models we said they do not exist in, assuming we made an assumption that they do not exist, and we would like to see them during the export process. So I set up the system in a way that it will replace a number of components. Use this synchronous machine and this AC line to represent the AC source which was previously connected to bus 2 and the transmission line connected between bus number 7 and 5. And as you can see, this appears here. To make sure that the replacement is happening properly, we can also export it one more time, but this time excluding the user library. So if we don't rely on this user library, it's going to rely on PRSIM components. So obviously, rather than seeing a detailed model at bus 2, we just see a AC source. And rather seeing a detailed model for the transmission line, we just rely on the PRSIM model, which is not anymore a frequency dependent one. So that's essentially the user-defined library feature for PRSIM. Again, I will reiterate that there are more to it. There are other ways to, for example, have a selection of components and replace all of them with the user models. Something like grouping. For that, we have an option named parameter grids, which allows you, you might be familiar with, which is a new feature in PSCAD version 5 as well, which allows you to essentially look at the models behind number of components and then change them at once. For example, what I can do here, this is another way for substituting this AC source with a detail one. What I can do is to do a right click on that model, go to its properties, and rather than having the master source, I can go and select from my user library G1, and then it will just replace this single component. I can do a global substitution, and I can replace all my AC sources with that detailed model if necessary as well. So for more details, please refer to our help document. That can be a good starting point. And if you have more questions, we will be happy to answer those as well. Let's move to the next feature, which is a network equivalent. And for this feature, we're going to now switch to version 5, PRSIM version 5, to do the transition. And what I have done here, I have already created, first of all, I have selected the right PSCAD version, which is version 5. I have already expanded the study area. I have imported the same case, which is the Contour case, with the system coordinates to make it faster. But unlike last time, we didn't fully expand the system. Let's say this is the study area of our interest, and now we are ready to export it to PSCAD. Obviously, this plus sign is telling us at bus number 67 with a name B08, there are more to it. There are more parts of this network which are still connected to this bus, and it is still expandable. But for the rest of the network, we have it on the study area, and everything is here except those parts that are missing. So what will happen during the export, since we have part of the system not included in the study area, we have a new module which is called network equivalent, which will appear during the export. What it does, it will look at the rest of the network which was connected to bus 8, bus B08, and it will build a Y matrix out of it, and it will do the necessary calculation from the large Y matrix to a reduced version of it, which represents only the missing parts of the system. And for example, if I dive into this module, this is going to be a simple AC source. The other two type of components which are normally will appear under this module are the transformers as well as RLC branches. And with the combination of those three, we make sure to model the rest of the system, whatever it is, for each specific case. Another cool feature is that we add a sticky note to all those boundary buses to make it easier for you to differentiate it from the normal bus bars in the system. So let's say that we are happy with what we are seeing here at this point, and we would like to send it to PSCAD. So once again, we launch PSCAD, but this time, what happens is that we will get PSCAD version 5. So everything happened again for the NETEQ, everything showed up. Now what you see on top of the normal AC components, we have this network equivalent module in version 5. And that's all about NETEQ. Again, more to it and more details. There are more details. You can also refer to our help document and also get back to us with your questions. And the very last feature that we want to try to cover together today is the re-initialization. And for that, I will just keep the same PSCAD file and I will start adding more details to it. And I'm going to add a multimeter. And that's where I said, essentially, when you start your EMT type of studies, you do lots of different things. For example, you may want to add multimeters. You may want to add more control parameters and then monitoring number of signals and stuff like that. But what you want to do after this is to, for example, further expand this bus bar, which is a boundary bus, and look into more details of the case. And obviously, you don't want to do the whole process again, importing the information, because that's not a big change. That's just updating the existing PSCAD file. So now I'm going to show you how to re-initialize an existing PSCAD case. Let's now first go to the folder where we kept all our files. So we go to the PSSE and version 5. And now rather than importing the normal PRSIM files, what we can do, we can import a PSCAD file. And that's what I'm going to do. We just save this file. We added, if you remember, we just added a simple multimeter. And now what we want to do, we want to further expand this case. So for example, let's imagine this is what we are interested in, further expand the study area. But what we don't want to do is to, again, for example, re-import the whole raw file, expand the study area, create a new PSCAD file, add all those extra signals. So that's going to be a time-consuming process. But instead of that, with the re-initialization feature, what you can do, you can load the PSCAD, an existing PSCAD case generated by PRSIM into PRSIM network workspace, and then here under the export to, there is an option from this drop-down list which allows you to select an existing PSCAD case. And rather than creating a new PSCAD case, we just update that existing PSCAD case. And let's see what happens when we do that. As you might have noticed, we are not anymore seeing that boundary bus as bus B08. Now it is B09. That's one small change that happened. The NETEQ also got updated. The NETEQ module is not anymore connecting a network equivalent system to bus 8. It is now connecting it to bus 9. So this comes very handy because, as you can see, we still keep the changes in PSCAD file. For example, this multimeter is still there. You can have more control signals and other monitoring devices as well in your PSCAD case, and you can keep those changes with this new feature, and you can update your PSCAD case. And that's all about re-initialization. So thanks a lot for spending some time with us today. We are super excited about all these features and the role that they can play in your transition to PSCAD and conducting EMT studies. If you have any questions about what we discussed on PRSIM in this first part of the presentation, please feel free to email us. We will ensure to answer them in a timely manner. And now I will pass it to my colleague to take us through the next step, which is PSCAD Initializer.
Okay, thank you. So you saw how cases can be imported from a load flow data file or with dynamics into PSCAD. And obviously, when you import data and develop your case based on a pre-solved load flow data file, your PSCAD will also be initialized, so to speak. PSCAD case will run at the same load flow conditions as your initial original starting PSSC file. But there could be situations where you want to change the load flow condition, right? For example, you may want to trip this line here in this simple case. You may want to trip this T line 1 and yet want to make sure that these two voltage sources or these three voltage sources provide the same power, right? But if you once you trip the line, unless you change the conditions of the voltage source, essentially the magnitude and the phase angle of the voltage sources, once you trip the line, you will not get the expected power flow. That will change, okay? Because the power flow between two buses separated by an inductor, for example, is governed by your simple power flow equation, P equals V1, V2 over X multiplied by sine theta, where sine theta is the angle difference between the buses, which means in order to get the necessary power flow in a meshed case like this, you have to set the initial phase angle of the voltage and the magnitude, right? So these are automatically brought into the PSCAD case when you import data from PSSC or some solved load flow file through PRSIM. Now, if you want to trip this line and still have the same power flow, you can re-import the case through PRSIM. You can go to your load flow file, you can trip the line, resolve your load flow case, and just like the last step that Afshin showed, you can re-import the case, right? And now you will again have the correct power flow. But maybe you don't want to go there, right? Or maybe you did not create this case using an existing data file. You probably just created this with data that were in data sheets, right? You just manually created the case without PRSIM. In that case, how do you ensure that you get the correct load flow? To do that, you obviously have to do a load flow solution, which we did not have in PSCAD for many, many years. Right? And we admit that that was one of our main drawbacks that we corrected and that we updated with the release of version 5. So now we have a feature where PSCAD, or the initializer tool that we are going to show you, will start with the PSCAD case that you built. It could be a so-called uninitialized case where you haven't updated the voltage source and dynamic device magnitudes and phase angles, or the initial set points, right? The initializer tool that we are going to show will take the PSCAD case you developed and derive from that the data file that is required to perform a load flow, okay? So that's the first step. From the PSCAD file, we will generate a network data file, so to speak. Then, using a load flow solution engine that we have developed for you, that comes free with version 5, this case would be solved. This case would be solved. And once you have a load flow solution, you can update the voltage source angles and magnitudes and the initial conditions of any other dynamic device. For example, if it is a wind farm, the initial conditions of a wind farm would be the voltage set point and the power set point. That's all. Or if it is running in the reactive power mode, it could be the power set point and the reactive power set point, as well as the initial voltage, and so on. So for any dynamic devices, once you have a load flow solution, the conditions, initial conditions that you need for any dynamic device or voltage source is available, and the initializer will update your original PSCAD case based on the solved load flow information. That's what the initialization tool does. So the default power flow solution engine that we provide to you with version 5, we call it PowerFlow Lite. It has been tested in-house over the past 3 years, and it does a very good job of solving, cases up to about 2,000 buses. That's where we have tested it. It is by no means an industry standard load flow solution engine. It should not. We don't recommend that you use it to do, load flow studies. It's good for PSCAD case initialization. Industry standard load flow is a different ball game. Like, there are a lot of features in programs like PSSC, DXIL, and PSLF that makes it very robust and industry standard for load flow studies. So also, if you want to, you can use our load flow solution tool, or if you already have PSSC, for example, instead of using our tool, you can tell the program to use your PSSC as the solution engine at this point. So with that, I will just demonstrate how this is done. So this, let us say, is a case that you developed. Okay. If I run this case, the voltage sources, it just initializes to some random P and Q values because I haven't updated the magnitudes, voltage magnitude and phase angle of these voltage sources. I want 50 megawatts to come out of this source. I want 240 megawatts to come out of this voltage source, but I'm not getting that. I'm getting some, random numbers. Okay. See, in the PSCAD voltage source model, you can actually set up the initial conditions for the voltage source, right? I want 240 megawatts, that's 2.4 per unit on a 100 MVA base, right? But I'm not getting it because my voltage source phase angle and also the terminal voltage were not set up properly. Okay. Maybe in this case, the voltage is what I want it to be. Phase angle, I don't know. I have to calculate it, right? Similarly for this voltage source. And in this particular case, if I select these two voltage sources as, generator buses or load buses or whatever, one of them should be the slack bus, should be the slack voltage source. So here you have to define this as the slack source. Okay. So what I do is let me save the case. So this is not giving me the right results. I have to now load this in a tool called the Initializer, which comes to you which you can download or which you can get from our sales team. So now, is this the case? Yeah. So I have to load my case. I have to load my case in this initializer tool. That's what I have already done. So you go to File, Open, and load the case. And once you load it, all you have to do is right-click and select and tell this program what your swing bus or the slack bus is, right? This program will automatically detect the type of the other buses. Of course, you can go to each one of the buses and specify that, okay, this is a generator bus, a load bus, and so on. But you really don't have to do that. The program is intelligent enough to determine it. And I think in every test that we did, it did a good job. But there may be situations where you have to go specify the bus type. But For circuits, simple practical circuits, you just have to define the swing bus and just say, run this case, run or run. So when you run, what the program does essentially is go through these steps, right? Generate the network data file, solve the load flow file, and update your PSCAD case, right? So I can run, it will ask me whether I want to rename this case, maybe you do, right? And then once you do that, you just go back to PSCAD and open the case. Okay, in a presentation, I don't want to do it online, so I had it run and initialized beforehand, so I will just load it. So this is my initialized case, the case that I just initialized through my initializer. And when I run that, see, now the power flow matches what I was expecting, right? Power flow is matching what I was expecting. If I go to the non-initialized case, obviously it was not giving me the expected power flow. If I go inside the voltage source model, of course, here I specify my expected power level and the voltage level, but my angle was, I didn't know what that angle should be for the voltage source. That's why I wasn't getting 2.4 or 240 megawatts. Now, if I go to the initialized case, the case that came out of my initializer, see, the phase angle in this case was updated, and also the reactive power level, which was 0 in the uninitialized case, this entry was 0, they were updated. So this will ensure that I will get 240 megawatts out and the bus voltage will remain at 1.03, my expected value, because I'm specifying this to be a so-called generator bus or a PV bus. Okay, so that's a simple yet complete demonstration of this methodology, initialization. Now, if I go to another case, uninitialized. So this case, instead of all voltage sources, has a generator, synchronous machine. Okay. Once again, in order to initialize the synchronous machine, all you need to provide to this machine model are the bus voltage and the angle for a specific power flow. Okay. The specific power flow that you want this to initialize to is provided inside either the generator model or the source model. If I go to this source model, right, the fact that you want this to be set to 50 megawatts or 0.5, you define it here. You just don't know the angle that would ensure this, that would ensure that 50 megawatts come out of it. So the initial conditions, the operating conditions, so to speak, the dispatch levels are defined by you in the source model or the generator model, or in the case of wind farms, in the wind farm page module. Now, in order for the initializer to work with synchronous machines or HVDC or wind farms, they have to be placed inside the page module for now. Otherwise, the program, the initializer wouldn't know how to integrate the circuit. Okay. Even if we refine this, I don't know if you could come up with a situation where you can initialize, very complex circuits with a lot of details, as you would have in a wind farm situation or a solar farm. So now in this case, once again, if I run this case, it will not initialize to the values that I want, but I can again load this in my initializer tool, right? Specify what my slack bus is. That's all you have to do. See, specify the swing bus, run the case, or when I say run, you're just initializing it and updating the initial conditions, and then you go to PSCAD and you run the case, you will get the expected load flow values, even with the dynamic device in the circuit. Okay, so when you say, so what this does is, this does a load flow initialization. The control initialization, the back initialization, to ensure that your controls, the status of internal status of these control blocks are properly initialized. That's a different aspect of initializing. Once you provide the load flow, initial load flow conditions, the PSCAD blocks, exciters, governors are already pre-programmed to perform a back initialization. So that's not a part of the load flow initializer. Load flow initializer just gives you these initial conditions: terminal voltage, expected power, expected reactive power, and the bus angle. You can see that these are variables. They are updated through our initializer. Did I miss any important points or no? So that's how it works. And now we see PSCAD being used to study, very large systems like hundreds and hundreds of buses, Australia, England, and it's just coming up. For those type of situations, I believe that re-importing through the initializer, re-importing through PRSIM, or updating the dynamic device initial conditions through a script would be the practical and the most appropriate way. But for smaller circuits that you may use to study, fast transients or whatever, you have the initializer. I mean, the initializer, of course, will work with large circuits as well, but then you do have to set up the case in a way that the initializer can interpret your circuit. And finally, PSCAD models of voltage sources and so on were designed for transient studies. So they don't necessarily have fields to input things like reactive power limits, and so on that you would consider in a load flow solution. So if you want to specify those limits, right, you can do that. But unfortunately, you have to do that inside the initializer. So you want to make sure that your generators don't exceed their capacities or reactive power limits, right? You can go to, let's say, bus 2 and update these fields. Where are those? Where are the limits? Qmax, Qmin, and so on, right? And if you don't want, if you don't want to do this, then all you have to do in the initializer tool is just select the swing bus. So I think that's all I wanted to show you in terms of the initializer today. And it's important, most of you know this, when you talk of initializing a PSCAD case or a EMT case to meet a specific load flow condition, all you have to do is update the magnitudes and angles of voltage sources and the conditions of other dynamic devices, settings of other dynamic devices, right? There's no initial condition updates for transformers, lines, and so on. Thank you very much.